Hello everyone, is my sound and screen visible to you? Please just make a comment, yes or no. All right. Means my sound is visible to you, my voice, and my screen is also visible to you. See, today we will do a very, very important topic of fundamentals of mathematics, that is log. This topic you guys will be using very frequently in chemistry also, in physics also, and undoubtedly mathematics also. So I am going to cover all the basic properties of log and everything about log. So consider it like a topic from scratch, and we shall be covering everything. And I'm sure that you guys are not really aware of log. Are you? Raise your hands if you are totally aware of log. Raise your hands and you just make a comment. Yes, we are aware. Anybody, please? JNV Yanam. Okay, you are aware of. Is there anybody who is totally aware of log? We will cover everything about it. Even if you are not aware of log, you may make a comment. No, we are not. Yes, please let me know if you are aware of log or you are not aware. Well, chalo, I got few comments not aware. Let's start. See, log is an operator. Okay. Say we have a number 49. This number can be written in two forms. There is a number 49. This number can be written in two forms. One is exponential form. Other is logarithmic form. All right. In the exponential form, I can write 7 square is equals to 49. So this 7 is what I call base. And this 2 is what we call power or index or exponent. All right. Now, logarithmic form में how can we write it? Log 49 7. What should be the power of 7 to make it 49? That will be your answer. Again, I repeat, what should be the power of 7 to make it 49? And it will be 2. That means 7 to the power 2 will become 49. So it is log 49 base 7. That means sometime if I see log x base a is n, this implies what? This implies a to the power n is equals to x. Very, very, very important. This is how we are going to understand the entire logarithm. Log x base a is n. That means a to the power n is equals to x. All right. Like if I ask you certain values, log 64 base 4, what will be the answer? Now we will going to do it like, what should be the power of 4 to make it 64? What should be the power of 4 to make it 64? So answer is what? Of 64. Log 81 base under root 3. Very good. Now, what should be the power of under root 3 to make it 81? Quickly, reply your answers in the chat box. Power of root 3 to make it 81. Which power of under root 3 is 81? No, which power of under root 3 is 81? 3 to the power 4 is 81. So root 3 to the power 8 will be 81. Answer is what? 8. Got it? Log 128 base 2. What should be the power of 2 to make it 128? Power of 2 to make it 128 quickly. What should be the power of 2 quickly? What should be the power of 2 to make it 128? That is 2 to the power 7. Very good. Log 100 base 4th root of 10. So we have 4th root of 10 to the power what? That will make it 100. See, I know 10 square is 100. So 4th root of 10 to the power 8 will make it 100. So your answer will be what? 8. Got it? Log root 2 minus 1 base root 2 plus 1. What should be the power of root 2 plus 1? That will make it root 2 minus 1. Now see, this root 2 minus 1 into root 2 plus 1 is what? 1. They are reciprocal of each other. So root 2 minus 1 can be written as root 2 plus 1 to the power minus 1. So root 2 plus 1 to the power minus 1 will make it root 2 minus 1. So answer will be what? Minus 1. One last question. Log 81 base 1 by 3. Tell me quickly. What should be the power of 1 by 3 to make it 81? Answer can be positive, can be 0, can be negative. What should be the power of 1 by 3 to make it 81? Yes, I am waiting. What should be the power of 1 by 3 to make it 81? See, 3 to the power 4 is 81. I can write it 3 to the power minus 1 to the power minus 4 is also 81. Very good. That means 1 by 3 to the power minus 4 is 81. So answer comes minus. Got it? Now, few think about log. Say it is a function log x base a. Now, when log is defined, this component of log, it should be positive. All right. This component of log, it should be positive. This is what we call base of the log. Base of the log. This base should be positive and should not be 1. Component of log x, it should be positive. Its base a, it should be positive and it should not be 1. These are the basic conditions for any log or any logarithmic function to be defined. Means log x base a defined only if x is greater than 0, a is greater than 0, and a should not be 1. Very, very, very important. Got it? So it should be defined if component is positive, base is positive, and base is not equal to 1. Note it down. Again, I'll explain. This log function is only defined if component of log x, it should be greater than 0. This base should be greater than 0. And this base should not be 1. See, we have logic for everything. But right now, we do not have enough time that I explain everything. You just remember this thing. Got it? All right. Now, see one thing, very, very important property. A to the power log n base a. A to the power log n base a. This value is equals to n. Very, very, very important. Log went to the power of a. So whenever this base a of exponential form and this base a of logarithmic form, if they both are same, this is equals to n only. Log removed, everything removed, n only. We can even prove it. This is very simple. Say log n base a is x. This implies what? N equals to a to the power x. Now substitute the value of x from there to here. So a to the power log n base. As simple as that. Got it? Now there is a simple question for you using this same property. Solve for x if 7 raised to the power log x base 7 plus 2x plus 9 equal to 0. Yes, tell me the value of x quickly. 7 raised to the power log x base 7 plus 2x plus 9 equals to 0. No. Value of x. Tell me quickly. Now see, what is this answer? X only. Using this above property, a to the power log n base a is equals to n. So 7 to the power log x base 7 is what? X only. So this is equals to x plus 2x plus 9 equals to 0. So 3x equals to minus 9 implies x equals to minus 3. Now tell me, can it be a valid answer? No. Why? Because this is your original question. In this question, x is the component of log. And just in previous page, I told you component of log should be positive, not negative. So once you got the answer as x equals to minus 3, this is rejected because of this point. So simply we will write this is rejected. So no solution. Got it? But yes, if the equation is like 7 raised to the power log x base 7 plus 2x minus 9 equals to 0. Now, this value is again what? X plus 2x equals to 9. So 3x equals to 9. So x comes 3. And 3 is positive. It is component of log also. This is totally valid answer. All right. Note it down quickly. Yes, it is accepted. It is a valid answer. Now, I'm going to write two questions quickly. Reply. 2 to the power log x minus 3 base 2 plus 2x plus twice of x minus 3 minus 12 equal to 0. Another question is log x minus 3 base 2 equals to 4. Okay, tell me the answers quickly. I give you 2 minutes. First question answer is 7. Very good. Very good. First question answer is 7. Yes. See, how is this? This will be directly x minus 3 plus twice of x minus 3 equals to 12. So thrice of x minus 3 equals to 12. So x minus 3 is 4. So x equals to 7. Very simple. Okay. Now answer to the second one. Quickly. See, 2 to the power 4 is equals to x minus 3. So x minus 3 is 2 to the power 4, that is 16. So your x is what? 19. Very good. Got it? Now we'll do properties of log. Properties of log. Now first and very important property, log m base a plus log n base a is equals to log m n base a. Very, very, very important. Log m base a plus log n base a is log mn base a. And now along with this, I am going to tell you which you should never use. Now what kids do? They do log m base a plus log n base a. Now they say take log common. Log common, log m plus n base a. This is totally wrong. Why wrong? Log cannot be taken common. Log cannot be taken common. It is an operator. It is with m, it will remain with m. Either directly take log m common or do not take anything common. So, but this is a very frequent mistake students do. So log m base a plus log n base a is log m into n base a. Very important. Now second property, log m base a minus log n base a. This is equals to log m upon n base a. All right. Log m base a minus log n base a is log m upon n base a. Now, third property, log m to the power p base a. Now see, what important thing is here, whatever the power of component is here, like p, you just bring this power out. It is p log m base a. Very, very, very important once again. There are not so many properties, but only 4-5 properties are there which are actually important. Got it? Now, Am I clear? Now write a simple question. Log x plus 1 base 3 minus log x minus 7 base 3 is equals to, say you have 2. Now, how will you solve it? Log x plus 1 base 3 minus of log x minus 7 base 3 is equals to 2. How do I solve it? Now see, using that first process, this property, this one, using this property. So what do I say? Log x plus 1 upon x minus 7 base 3 equals to 2. This implies x plus 1 upon x minus 7 is 3 to the power 2, that is 9. All right. Am I clear? So it is 3 to the power 2, that is 9. Now, if I multiply it, x plus 1 will be 9x minus 63. Clear? So this implies 8x will be what? 64. So x comes 8. Now, always verify in log, always verify that the answer you got is actually satisfying the first equation or not. Don't check it in this equation or in this equation. And not here. Always check it in the original problem given to you. Now, if you satisfy x equals to 8 here, so it will become log 1, that is 0. 8 plus 1, 9 by 3. Log 9 base 3 is 1. So it is satisfying. So whatever the answer you are getting, always check it in the basic equation. First, JNV Chitradur, please mute yourself. All right. Now, write down another question. Log x square base 2 is 1. Log x square base 2 is 1. Implies x square comes what? 2. So x comes what? Plus minus under root 2. All right. Easy and simple question. See once. Now see, there is a question. Before proceeding further, we'll do this question first. See this question. Solve the equation log base 3, 5 plus 4 log x minus 1 base 3 equals to 2. Yes. You got 1 minute, quickly do. Okay. JNV Panchvati, my voice is not audible. Is that so? Is my voice not audible to you? Is my voice not audible to anybody? Other JNVs, please reply. Is my voice audible? Now see, how do we do this question? First of all, this is the initial component. So if you remove this log, this will become what? 3 to the power 2. That means 5 plus 4 log base 3 x minus 1 is 3 to the power 2, 9. Means 4 log x minus 1 base 3 is 9 minus 5, 4. So from here, log x minus 1 base 3 is what? 4 by 4, 1. So x minus 1 will be 3 to the power 1, 3. So your x is 4. Got it? Your x is 4. This is the answer. Am I clear? Now, as another property of log, there is an important property that is base changing theorem. Base changing theorem. Now, according to this theorem, what do we do? Say we have log m base n. So that is log m base b upon log n base b. What this theorem states that the quotient of the logarithm of two numbers, quotient of the logarithm of two numbers, quotient means division. So quotient of the logarithm of two numbers is independent of their common base. See, this value is log m base n. So it has nothing to do with which base is this one. It can be 10, it can be 20, it can be e, it can be anything. So this base has nothing to do with this number. So quotient of the logarithm of two numbers is independent of their common base. All right. Is independent of their common base. We can prove it even very easily. Say if I give you the proof, log m base n, let it is x. So m comes what? N raised to the power x. Now take log both side at common base. So log m base b is log n to the power x base b. Now I'll take this x outside. So log m base b is x times log n base b. So x is what? Log m base b upon log n base b. Simple. And this is what you have assumed as x. Got it? Now see, like you are trying to find out the value of log 64 base 128. Now you are not getting an exact idea that what should be the power of 128 to make it 64. So what do? They are powers of 2. So break the log. Log 64 base 2 upon log 128 base 2. Now numerator is what? What should be the power of 2 to make it 64? 7. Sorry, 6. What should be the power of 2 to make it 128? 7. So your answer is 6 upon 6. Got it? Now, another very important thing is log A base B and log B base A. Log A base B and log B base A are reciprocals of each other. Log A base B and log B base A are reciprocal of each other. Why so? Log A base B can be written as log A base K upon log B base K. Common base pe we can break it. And log B base A can be written as log B base K upon log A base K. Now, if you see, they are reciprocal of each other. All right. That means log B base A into log A base B is going to be 1. Log B base A into log A base C is going to be 1. Now, see, there is a very simple question on the same concept in my file. Chalo, not exactly here. I'll write it for you. Write down a question. Find the value of 1 upon log ABC base A plus 1 upon log ABC base B plus 1 upon log ABC base C. Yes, you got 1 minute with you. Quickly explain the answer. Quickly do. Very good. 1 is the correct answer. Anybody else? See, very simple question. 1 upon log ABC base A. Its reciprocal will be log A base ABC plus log B base ABC plus log C base ABC. Yes or no? So now using the first property, log M base A plus log N base A is log Mn base A. So it will become log ABC base ABC. Now what should be the power of ABC to make it ABC? Power should be 1. Got it? Now, see, if sometime I have log B base A into log C base B into log D base C and so on, log say P chalo, we'll manage up to this point only. Log D base C into log E base D. What is the answer? See, if I change the base and apply base changing theorem, can I say it is log B upon log A, log C upon log E, log D upon log C, log E upon log D. Got it? Now, this log B cancels this log B, this log C cancels this log C, this log D cancels this log D. What you are left with? Log E upon log E. So this is equals to log E upon log A, which can also be written as log E base A. So simple and important property. Very good. JNV Ahmedabad, very good. Got it? Now there is a question on this property. See this one. X is log BCD by 2 base 2A. Y is log ACD upon 3 base 3B and so on. Then find the value of 1 upon log 1 plus X, 1 upon log 1 plus Y and so on. Quickly attempt. Yeah, I got to know you have seen the answers in the bottom. 120. Solve it quickly. Yes. See, X is given to you as log BCD upon and base में it is 2A. All right. So X plus 1 will be what? Log BCD upon 2 base 2A. And this plus 1 I can write base में 2A upon base 2. 2 log 2A base 2. Now if I merge both of them, I am going to get BCD by 2 into 2A and base is also 2A. So it is log ABCD base 2A. Am I clear? Similarly, y plus 1 if you calculate, you will get log ABCD base 3B. Z plus 1 will be log ABCD base 4C. And W plus 1 will be log ABCD base 5D. Got it? Now they are asking for the value of upon X plus 1 upon Y plus 1 plus 1 upon Z plus 1 plus 1 upon W plus 1. So 1 upon X plus 1 is 1 upon log ABCD base 2A. 1 upon Y plus 1 is 1 upon log ABCD base 3B. 1 upon log ABCD base 4C. 1 upon log ABCD base 5. Got it? Now, reciprocal of all of them. This will become log 2A base ABCD plus log 3B base ABCD plus log 4C base ABCD plus log 5D base ABCD. So it will be log, multiply all the components, 120 ABCD base ABCD. That is log 120 base ABCD plus log ABCD base ABCD. Yes or no? This value is 1. So answer 120 is ABCD. So this is your N. Got it? So they were asking for the value of N, and that value of N is 120. Have I made my point clear? Now, this question we have already covered. Okay. And another important property. See, a to the power log b base c. A, very important, see very carefully. A to the power log b base c is also equals to b to the power log a base c. These b and a can be interchanged. A to the power log b base c is b to the power log a base c. Yes. Now, how did I get it? Before that, one very small thing I'm going to tell you. A to the power bc is also equals to a to the power b to the power c is also equals to a to the power c to the power b. Simple rule of indices. All right. Now, they have given you a to the power log b base c. This b base c, I'm going to change its base. So a to the power, I can write it log b base a into log a base c. So if I change their base, log a will cancel, it will be log b base c. I can also write it a to the power log b base a whole raised to the power log a base c. A to the power log b base a whole to the power log a base c. And now this value, this is what? B. So it is b to the power log a base c. Got it? B to the power log a base c. And this is again very important. Now there's a question on the same concept. See, this is 2 times x to the power log 3 base 4 plus 3 to the power log x base 4 is 27. Now, don't you realize this value and this value, they are identical? Why identical? Because this x and 3 can be interchanged. So this 3 to the power log x base 4, keep it as it is. This x to the power log 3 base 4, I'm going to change it 3 to the power log x base 4. So 2 times 3 to the power log x base 4 plus 3 to the power log x base 4 is what? 3 times 3 to the power log x base 4 is 27. Means 3 to the power log x base 4 is 9. That is 3 square. So log x base 4 is 2. Implies x is what? 4 raised to the power 2, that is 60. All right. So again, important question, good question, and using a very good property. Got it? Now, one more question I'm going to write. I won't solve it thoroughly. I'll give you a hint. Got it? Question is x plus 1 raised to the power log x plus 1 base 10 is 100 times x plus 1. X plus 1 raised to the power log x plus 1 base 100 is 100 times x plus 1. It's such kind of question where this base is in terms of x, power is also in terms of x, or here it is in terms of log. What do we do? Taking log both sides. Taking log both sides. So it will become log x plus 1 raised to the power log x plus 1 base 10 is log 100 times x plus 1 base 10. Got it? Now this entire power of component will come out using third property. So it will become log x plus 1 base 10 into log x plus 1 base 10. This will become log 100 base 10 plus log x plus 1 base 10. Yes or no? Now, assume log x plus 1 base 10 as t. So you will receive t square equals to t plus 2. Log 100 base 10 is 2. So it is t square minus t minus 2 equals to 0, which is a quadratic which you know how to factorize. So you factorize it, get the value of t, from there get the value of x. And always remember, once you get the values of x, always satisfy in the original given question if it is fine or not. Got it? One more thing, very simple, easy thing I will like to tell you. If sometimes we have log x base e, this e is what we call, this is Napier's constant. Napier's constant. This e lies between 2.7 to 2.8, and it is also an irrational number. So this log x base e, this is what we call natural log. Natural log, and it is also written as ln of x. So wherever you see ln x, we directly call it log to the base e. All right. See, I explained this question once again. Somebody was asking me. X plus 1 to the power log x plus 1 base 10 is 100 times x plus 1. All right. Take log both sides. Definitely, if question is talking in terms of base 10, we will take the log to the base 10 also. Taking log base 10 both sides. So here it will become log base 10 into this entire expression as it is log 100 times x plus 1 base 10. All right. Now this power will come outside. So it is log x plus 1 base 10 into this log x plus 1 base 10 is log 100 base 10 plus log x plus 1 base 10. Now assume log x plus 1 base 10 as t. So there will be quadratic t square equals to t plus 2. You just solve this quadratic, get the values of x. Well, this is all for the day. Take log seriously. Remember all the properties. I'm going to launch a small poll and about your experience with the class. Please reply to that. There you go. Start quickly, then we'll end the class.